Structural equation modeling is seen widely used in many fields of research, but not much seen in educational research. So, hereby I thought of suggesting or recommending the use of SEM, which has a high potential to be of assistance to modern educational researchers. So, in this presentation, I will be explaining what is structural equation modeling, what are the major components involved in it, what are the major steps involved in it, how you can represent the structural equation models using part diagrams, what sort of research questions would SAM be particularly suitable for addressing, and what are the different software packages available for fitting SAMs. So, moving on to the first one, that is, at first you should know what is structural equation modeling. It is a comprehensive statistical approach. So the structure equation modeling, it is a comprehensive statistical approach to testing hypotheses about the relationships among observed and latent variables. You see, latent variables are the unobserved variables, and the research scholars in education field, are mainly focused on such latent construct or hypothetical constructs which can't be measured directly, but we are measuring it through some items, observable items or measurable items. So the structural equation modeling helps in testing the hypothesis and finding the relationship among these observed and latent variables. And you see, it allows the simultaneous analysis of a series of structural equations that will be shown to you here in the slide itself, how it analyzes a series of structural equations. Structural equation modeling incorporate both unobserved and observed variables, while other multivariate techniques are based on observed measurement only. The multivariate techniques like multiple regression analysis, multivariate analysis of covariance, correlation, these are purely based on observed measurement. Whereas structural equation modeling, that is the most important fact about structural equation modeling. It deals with unobserved variables, or it incorporates both these variables, unobserved and observed variables, and help in testing the hypothesis. So let us see more about it. Structural equation modeling will have these two as major components. The one is a measurement model and the other one is structural model. So most of the psychometric measures used in educational research are latent variables. Means it can't be measured directly, as it cannot be directly observed. And SCM provides you the way to measure these latent variables through validated indicators. How you can have such validated indicators? The question will be answered by understanding what is measurement model and what is structural model. Before that, let me say SEM, that is structural equation modeling, is actually a combination of two statistical methods, confirmatory factor analysis and path analysis. Confirmatory factor analysis originated in psychometrics, and it has an objective to estimate the latent and psychological traits, whereas the path analysis have its beginning in biometrics, and it aimed to find the causal relationship among variables by creating a path diagram. So these two combine together to form structural equation modeling. Actually, path analysis is a special case of SEM and has a more restrictive set of assumptions. The main difference between the path analysis and SEM is that path analysis assumes that all variables are measured without error. While doing path analysis, we cannot find the relationship through along with the measurement error. Whereas in SEM provides you the way to find the relationship among latent variables and observed variable, giving account or considering the measurement error. That is the main difference between path analysis and SEM. So I thought of saying SEM, or I wish to say that SEM can be thought of as path analysis using latent variables. So you can see here some path diagrams are given. Actually, in path analysis also you will be having some diagrams like this. But in path analysis we never use latent variables. But here you will be having the provision to use latent variables to find the causal relationship among these latent variables and observed variables. So let me make you more clear. Here you can see the first one, that is a measurement model. These are the two major components I told you. And in this measurement model, all the constructs in the study, okay, the constructs in your study are drawn and then covariate with each other to perform CFA. Here you see, here A is given. A indicates that is a latent variable, and this latent variable will be always included, or it will be treated in an ellipse. in this under this structural equation modeling, you will be having some standard notations. So the ellipses always indicate latent variables, and the rectangular boxes or the square boxes indicates observed measures. So the latent construct, for example, motivation, aptitude, etc. Latent construct. How can we measure motivation? We can't measure it directly, isn't it? We can measure the height of a person, we can measure the weight of a person. Those all are observable or measurable. But some latent constructs, psychometric measures like intelligence, aptitude, motivation, etc., cannot be measured directly. And these can be called as latent constructs or hypothetical constructs. And these constructs, we actually observe or we measure them using indicators. So here you can see x1, x2, x3. These are the indicators. We will be asking many questions. We will be formulating a questionnaire, and we will be having many questions or items in the questionnaire. So each item will be taken here as an indicator. And here you see at in the first step, these constructs in the study will be drawn like this and then covariate with each other, and we will perform confirmatory factor analysis. So after running confirmatory factor analysis, it tells you how well the indicators measure the unobserved constructs. So these unobserved measures, unobserved constructs or latent constructs will be measured using these multiple indicators, and by performing confirmatory factor analysis you will be able to find how much or how well each of the indicator measure this unobserved construct. If you find that any of these indicator is not much correlated with this construct, by having the readings of factor loadings, we call it factor loadings. So if the factor loadings are near to 1, it says that your indicator is well good for measuring this construct. But if the factor loading is very less, you can see that, or you can predict that this variable or this indicator is not well to measure the unobserved construct, and so that you can delete that particular item. So here in this step, you can actually find the reliability and validity of the construct. So without relying on any other particular methods to establish the validity and reliability, by using the measurement model itself, by running the confirmatory factor analysis, after during the measurement model assessment, you can find and you can examine the quality criteria of the construct, and you will be able to assess the model fit. The model fit means how your data fits into the model. So that model fit gives you the value that if your model is good or not. If the model fit value is very bad, if it is not good, you can improve your model fit by either making many other covariances, or simply by eliminating or rejecting those indicators having measurement error. Okay, so like that you will be having a good model with you then. So after having a good model, you will be moving on to the next stage, that is a structural model. So here you can see the structural model. So after running measurement model assessment, you will go on to a structural model assessment. So here the theorized link between the measurement model for independent construct and the measurement model for dependent construct generates a structural model. You can see here A and B given. A and B are latent variables, and these latent variables are A will be measured using x1, x2, x3, some indicators or items or questions, whatever it be, and B also, it is a latent construct. It will also be measured using some indicators. And here you see the arrow from A to B. It says that B is a dependent variable. Dependent. It means B depends on. So here in SEM, that is in structure equation modeling, we call it as endogenous variable. So dependent variable, we call it as endogenous variable, and independent variable will be called as exogenous variable. And in the structural model assessment, the hypothesized relationship between these variables, sometimes you will be having more than 2-3 latent constructs in your study, so you will be having many more structural equation going on. Here you can see only two equations here, only two. One measurement model of independent and independent construct, and the other measurement model of a dependent construct. So according to your study, according to the varying nature of your study, you will be having more constructs and more indicators. Okay, so here I have just given an example. So the hypothesized relationship between these latent variables can be examined using structural model or structural equation. This is the structural model or structural equation. And after running SEM analysis, so in this stage, when you run the SEM analysis, you will have a t-value. And if you find the empirical t-value to be larger than the critical t-value, the null hypothesis gets rejected. That is how we proceed on to the analysis part. And you see here the part diagram of a true score equation. As I already told, SEM always deals with, or the special nature of SEM is that it is able to find the relationship among latent variables and observed variables. So one another specialty of SEM is that these latent variables are measured through observable indicators of the key constructs, and they are often measured with error. This is not possible in any other analysis, okay, or very less possible with some other type of analysis, because here you will be having, you will be able to measure the latent construct through observable indicators. Along with it, you will be having the measurement error also. So here you see the equation: measured variable is equal to true score plus measurement error. So by understanding the measurement error, it will give you more easiness to proceed your data and to identify how to rectify this measurement error and to proceed your analysis part. Here in this paper, in this slide, you can see one another example. Here you can see multiple indicators are used. These multiple indicators measure the particular variable. Here the latent variables are given in ellipses. You can see here the measured variables. These latent variables are always latent variables or unobserved variables. These latent variables are always indicated in ellipses in structural equation modeling, and the observable measure, okay, observed measures are always indicated in rectangular or square boxes, and arrows will also be indicated like this. So each latent variable of your study can be measured using such multiple indicators. And by running at the first step, I already told you in the first step, that is by running the measurement model assessment, you can find the factor loadings through confirmatory factor analysis, and you can see how each of these indicators measure the construct. And if you find the indicator is not good in measuring the particular construct, you can neglect or you can avoid that item, okay, as we do in item analysis. So that is easy, that makes it more easy. Reliability, validity, everything will be established in the first step itself. So here you can see this is a structural model, and here you can see many latent variables used in this particular model. Here you can see one double-headed arrow. It indicates a covariance. So these are all hypothesized relationship, and when we run the analysis, we will be able to get a point or a value which indicates if the um, relationship is well organized or if it is valid or not. Like that, we can proceed with our study. Here also you can find one another example of a study. For example, you see language, motivation, stress and positivity. These are the four latent constructs used here. Language, you know, it cannot be directly measured. We measure it using some questions or items, isn't it? So language can be measured using the ability of using language, or language proficiency will be measured using some questions related to grammar, some questions on vocabulary, comprehension, organization of ideas, something else like that. So these items will also, or these scores will also be given to us by through along with the measurement error. And here you see how motivation, stress and positivity have an impact or influences language. So for each of these, motivation, stress and positivity, these are also latent construct, and for these latent constructs also measured using indicators. So motivation 1, motivation 2, motivation 3, these are the indicators or these are the items, means the questions you use in your questionnaire. So these all are measured with its values, and so these lambda coefficients and the values given here helps you to find if this particular indicator is good in measuring this particular construct. If it is not good, you can delete it from here itself, okay. Thus you can proceed with your study. And now you should understand what are the steps for conducting SEM. The 5 steps here: one is model specification, the next one is identification, estimation, evaluation and modification. Model specification defines a hypothesized relationship among the variables in an SCM based on one's own knowledge, based on previous literature or review of literature. You will make some predictions or you will assume some relationship. So according to that, you will be having a model. It is very easy to create such a model, such a part diagram using Amos software and Onyx and so many other softwares. Now SPS is also built with Amos. So that model specification is the first step, which is very easy with these set softwares. And the second one is model identification. That is to check if the model is over identified, just identified, or under identified. And you see, only if it is just identified or over identified models, these models will be having model coefficients. So the model coefficients can be estimated. The third step, that is model F coefficients, will be estimated only if it is just identified or over identified model. And the next step is model evaluation, that is to assess the model performance of it with quantitative indices calculated for the overall goodness of it. Means you should see if the model fits to your data, that is model evaluation. And if you find that the model fit is not good, what you can do is the last step, that is model modification. You can adjust the model to improve the model fit and improve the reliability and stability of the model. So these are the steps in conducting SEM, that is structure equation modeling. And the next we will talk about the software packages available now. There has been a list of software packages that are available for fitting SEM, that is structure equation modeling, and this list keeps on changing and growing all the time. And the best known software package for SEM is LISREL, LISREL, and it was developed by Carl Jokson and Sobam, and it was one of the first available package. And you know, now due to the increased popularity of SEM in many other fields of research, many software packages including EQS, then Amos, SAS, M+, Onyx all are available for the researchers to carry out the related analysis. And Onyx, the last one, Onyx, it is a freely available one. It is a free package that is available freely for the researchers to download and to analyze sophisticated theoretical models of complex phenomena. So I think when you are doing a research in educational research, especially when you are focusing on some psychometric measures like motivation, aptitude, stress, which can't be directly observed, which can't be directly measured, those we call it latent constructs or hypothetical constructs. And the relationship among these can be very well established, or these relationship can be find out using such a comprehensive statistical approach, structural equation modeling. I hope it's clear to you. I hope it will be of use in your research. Thank you.